Hello everyone. Today we're talking about rotations. Let's get started with some descriptions and rules. So when you talk about rotations, we're talking about figures that are being turned, about a fixed point. As such, rotations are sometimes called turns. Now this fixed point, for the most part, is also going to be known as our origin, or point 0, 0 in the coordinate plane. Now there are a few rules for how we're going to rotate things around our origins. We can have 90-degree clockwise rotations, designated by clockwise or CW, wherein we're going to swap with the position of x and y, and we're going to make the former x negative. We can also do a 90-degree counterclockwise, or CCW, wherein we're going to take our normal coordinates, we're going to flip the positions, and we're going to make the y negative. Finally, we can have a 180-degree rotation. It doesn't matter if we go clockwise or counterclockwise, because 180 degrees is basically a reflection. And just like a certain reflection that we covered a few days ago, we take our x and y, and we make them negative. Now, important things to point out, to note, just like our previous two concepts, with rotations, our shapes are not changing, they're just changing position. So we're still going to have congruent shapes. And since the shapes are congruent, that means the corresponding sides are congruent, and the corresponding angles are congruent. Just something to bear in mind. All right, let's take a look at some examples. We want to rotate this triangle 90 degrees clockwise. We're going to take our x and our y, to rotate them 90 degrees clockwise, we're going to turn them into y comma negative x, such that our A, B, and C will go to, let's see, A will go from 2, 3 to 3 comma negative 2. B will go from 3, 1 to 1 comma negative 3. And C will go from 1, 2 to 2 comma negative 1. Now at this point I'm going to pause the video to draw this out, and then I'll restart when finished. So here we have our rotated figure that we have rotated 90 degrees clockwise. Oop, 90 degrees clockwise, such that our A has rotated from here to there, B has rotated to here, and C has rotated to here, to give us A prime, B prime, and C prime. Example number 2, we're going to rotate that rectangle 90 degrees counterclockwise. A 90-degree counterclockwise rotation means we're going to take our x and our y, and we're going to adjust them by going negative y comma x, such that our m will go from negative 5, negative 3 to 3 comma negative 5. A will go from negative 2, negative 3 to 3 comma negative 2. T will go from negative 2, negative 5 to 5 comma negative 2. And H will go from negative 5, negative 5 to 5 comma negative 5. So once more, I'm going to pause the video, draw it out, and then come back to y'all. And so we've rotated our figure 90 degrees counterclockwise. such that our M has rotated to there, A has rotated to there, T has rotated to there, and H has rotated to there. Last example, we're going to rotate this triangle 180 degrees. When we rotate 180 degrees, that's basically a reflection. So we're going to do our x and y will become negative x, comma, negative y. So a of 2, 3 will become negative 2, comma, negative 3. B of 3, 1 will become negative 3, comma, negative 1. And C of 1, 2 will become negative 1, comma, negative 2. And so we've rotated our figure 180 degrees around the origin. Now it doesn't matter which way we're going, either clockwise or counterclockwise, because as mentioned, a 180 degree rotation is essentially a reflection. In this case, it looks like a reflection across the y equals negative x diagonal, going back to our 9.1 notes. All right, so let's take a look at a pair of practice problems. Practice number 1. We want to graph and label the pre-image, then rotate it 90 degrees counterclockwise around the origin. So I'll be doing the pre-image in red and the new image in blue. But first, let's put out our coordinates. Because we're going counterclockwise, we're going to take our xy situation. So xy is going to become negative y, comma, x. Such that my a prime will become 3, comma 2. B will become b prime at negative 1, comma 2. And C will go from negative 2, negative 2 to C prime of 2, comma, negative 2. So we took our pre-image here in red, and we rotated it 90 degrees counterclockwise to give us our image in blue. Now because they overlap, I've not labeled the point specifically, but essentially we have a counterclockwise rotation of 90 degrees. Practice number 2, similar sort of thing, except now instead of a clockwise or counterclockwise rotation, we're going 180 degrees. 180 degrees means we're going to take our xy, and it'll become negative x, negative y, such that our e value of 4, 4 will become negative 4, negative 4. F of 4, 2 will become negative 4, negative 2. And G of 1, 3 will become negative 1, negative 3. And so we've rotated triangle EFG 180 degrees around the origin. And of course, it doesn't matter which way we go, because a 180 degree rotation is essentially a reflection. Now that concludes the notes for today. As always, if you have questions, please let me know. If you'd like to look at the additional back page, there are a few more examples that go over the same information here, just in a slightly different format. If you would like to go over them, shoot me that email, ask during class. I'd be happy to check your answers for you. Take care.